Okay, so here's the next problem for the problem of the day, that is partition labels. Okay, so we were not able to upload yesterday's problem, so due to some health reason, but yeah, so here's the next problem. We will continue it from today. Okay, so here what the question is saying, we have given a string s. Okay, you can see in the example. Okay, and we have to make the partitions and return this output, and this output is the size of the partitions. Okay, different partition from this string. Okay, so 1 9 and 7 1 8. Okay, so this is the basically question, and you can see we have to return a list of integer representing the size of this parts. Okay, we don't have to return the this strings, okay, in the form of answer. We have to just return the size of the partition. Okay, not the partition itself. So this is basically the big question. We can simply understand from the smaller question. Okay, so this is the smallest string. You can see also here I have taken this example. Okay, so if you understand by the smaller, then it will be good, and then we will go to larger string, so that you will basically you will main purpose is here is to understand you the question. Okay, explain you the question. Okay, so what question is saying basically, so how we should have to basically make the partitions. Main thing is that, okay, so partitions are made if, okay, like if we make two partition, that is this. Okay, so in both partition, if any basically character is present, then all the occurrences of that character should be in that partition. Okay, basically this is the main thing. Okay, if you partition from here, okay, like if I draw the, if you partition it from here, then if you see at this partition and this partition, all the occurrences of this A and this B are the occurrences. Okay, these are the character. But if you see in this partition, A and B are also present. Okay, so we can't do this. We have to partition this in this. Okay, in these two partitions, because all the occurrences of AB will be here. Okay, simply, and all the occurrences would be of C will be here. Okay, you can't make any other partition of this question. Okay, of this example, if you make this, then C will be at this partition. Okay, so main here thing is that all the partition, basically all the characters of any partition, or all the basically occurrences of the character should be on basically on any partition. Okay, not like one occurrence is here, one occurrence is there. Okay, so all the occurrences like here A and B, so possible A is 2 times, B is 2 times in this whole string, so both, so whole occurrence will be at this partition, and C is also 2 times, so this would be at this partition. Okay, so if just if we change this string, if this was like this. Okay, so let's just take the example and change it like this. Okay, so if this string was like this, okay, then we can make 3 partitions. Okay, simply like from here, that is A, and this is BB, and this is CC. Okay, simply, so the answer would be like this would be the simply the answer for this question. Okay, for this. Okay, so you basically got the question. Main thing is that in partition there should be all the occurrences of the basically all the characters that is present in. Okay, so this is the, let's just understand this question. Okay, so a much big basically input, so that you can understand. Now basically main approach you have understood. Okay, so let's just take this and you will get how the answer has come this. Okay, so let's just take it, then we will go on the approach. Okay, one last example we will discuss. If you see the first basically letter is A. Okay, and then if you go, then our first main thing should be, if you just think of simple approach, then if A is there, then we have to just think of this last occurrence. Okay, So last occurrence is here. So you basically know that one possible partition is here, okay, and next it depend on the next variable, okay, that is b. So b's last occurrence is here. So the final basically now till now the last occurrence is here, okay. So main partition size is here. So we will check for every character their last occurrence, okay, so that we can get the final partition. So what we'll do here, a's last occurrence is here, okay. So we can take 2 pointers. First this will simply get at the partition start, okay, and this will get at the partition end. Why? Because its last occurrence is at here, okay. So simply then we will check for b. So b's occurrence is within this occurrence, so it doesn't matter, we don't have to change the last occurrence, basically partition end, okay. Then for c, then it is also in between the partition, okay. So final one partition would be this. So you can count this 4 and this 4 8 and 1 9, okay. So that's why first output is 9, first partition you can say. So let's just take this and partition it, okay. Then we will go on the next partition, okay. So then we will check for d. What is the last occurrence of d? So d's last occurrence is here, okay. So first we can say the our partition would be here. Then we will check for every variable in this partition, okay, so that we can calculate its last occurrence, okay. So then e. So e's last occurrence is more than d. So we can simply say our partition would be greater than this, okay. Then we will check for f. So f is single, so its last occurrence is this only. Then we will check for g, then okay. So g's occurrence is also not there. So simply the largest occurrence in which all the characters are there, all the occurrences of the character are there. So simply this will, okay. So you can count this 4 and 3 7, okay. So that's why the answer is 7 here next, okay. Then we will check for next. So simply you can say this h, okay. So this is h, okay. Simply the last occurrence of let's just take one more, okay. First we will see the last occurrence is this, okay. So okay, then we will check for I. So then the R partition would be stretched, okay, because I has come. Then we will see J, then our partition would be simply this. So whenever so basically the partition come to end, so this whole thing is a partition, okay, then valid partition. Then we will simply get the size of this, that is 8. You can count also basically 3 6, then 2 8, okay. So simply 9 7 8 you can get the all partition, okay. So basically you got the approach, okay. So let's just understand it with example, okay. So let's just understand it with example. So what we are going to do is we are going to take 2 pointers, okay. First will be simply partition partition start, and next would be partition end, okay. So simply those will start from the 0 index, okay. So if I just make it big, okay, it will start, both will start from the 0 index, okay. So if you see, and one thing we will take care of the thing is that we will calculate first all of the occurrences of last occurrences of the basically variables, okay. So what we will do, we will create a array, okay. Okay, so partition start would be simply at this first, and then we will check for a. So first element is a, simply we will check for its last occurrence, that is 8. So last occurrence is at this position, okay. So simply partition it would be and will be come here, okay, simply. Then we will move this, and then we will every time check its partition end. If it is greater than basically this a, then we will simply move partition end, but it doesn't basically getting something because b's occurrence is smaller than a, okay. So simply we will not move. then we will simply push it, basically iterate, and then whenever I will come at this partition end, so whenever this I is equal to partition end, then we will get, we have found the valid partition. Okay, then we will simply form this answer. I can write here, it is 9. Okay, so simply we will find this valid partition whenever I is will be equal to partition, and because we have reached the final partition of a, basically final last occurrence of all the unique characters present in this partition. Okay, then we will simply update the partition start also, then it will simply come at the I plus 1. Okay, that is basically D. Then we will check for D, then its partition end would be at some here, then okay, then simply we will move I, then whenever E would come, so E's last occurrence would we check, so simply it would be greater than D, so simply partition end would be partition end will move further. Okay, then same I would move, then simply whenever I will be equals to partition end, then simply partition start would be moved forward, and then simply we will update the answer, that is simply 7. Okay, and then same thing will happen, and last the answer would be simply 8, and we can simply the loop will exit whenever I will exit this. I will basically iterate whole string. Okay, so simply this is how our approach will work. Okay, so that's the approach. We will see the code in. Okay, so here's the Leetcode. I have written the code. Okay, so first we have taken this array last occurrence. Okay, that will simply have this basically 26 size of all, basically 26 is representing the all the alphabets. Okay, so simply we will update the frequency. Okay, that not frequency, basically indexes of the last occurrences. Okay, so simply this is like si minus a, that is simply give the ASCII value of the that character. Okay, and then we will simply update the value with the index. Okay, last occurrence. Okay, then simply this we have taken this partition and partition start, that variable. Okay, we will simply take of this result, that will simply give result. Okay, then we have simply used the loop, and for basically iteration from start to end. Then we will every time partition end would be simply max of partition end, and last occurrence of the this character, that will simply come in the iteration. Okay, so we have seen, okay, last occurrence would be simply at the last. Okay, then anytime if I is equals to partition end, then simply we have got the valid partition. Okay, then we will simply push back the size of the partition. Okay, that is simply I, that is the index minus partition start plus 1, because it is 0 index, that's how we have plus 1. Then we will simply move partition start to that next element of the partition end. Okay, look for next valid partition. Then we will simply this loop will work, and we will simply output the result. Okay, then you can submit it. One thing I think what has done. So it's saying that I have, okay, so here's the problem. It should be S. Okay, so let's submit. So yeah, you can see it beats 100%, and you can see time code. It's big of n because it's not using anything. Simply, and you can see memory. You can simply say it is big of 1 because it is the result part. Okay, so simply, so that was the code. Okay.